And there it is through the magic of stop action. We have a resistance here, an inductance here, a capacitance here, and a source voltage here. So that's what we're talking about. You should have a picture of that, taking notes as you view the videos in any case. So you should have that in bigger form as we saw it earlier. Okay, well, if that's the case, then without going through all the details, which we kind of went through last time with a mechanical system, it should be clear to you, especially since this is presumably something that you have just been over in differential equations course. We get Q equals e to the negative r over 2lt, right there it is, and then plus or minus, well, this is imaginary, so we're going to have a cosine of omega t, a combination, linear combination of cosine of omega t, sine of omega t, with omega equal to the square root of r squared over 4l squared minus 1 over lc. This thing. This being, I should say omega equal to the magnitude of this, because, of course, this thing is an imaginary and omega is a real quantity. So, but in any case, there's our omega. And note again, if 1 over LC is small compared to this just comes out close to R over 2L. So it has a magnitude close to R over 2L, but that won't make the thing oscillate. That would result in a positive term here, and that's going to drive you to exponentials. So you might want to think through what happens in this case, which we're not talking about today. Okay, so we get omega equal this, and now we want to solve the non-homogeneous equation here, so we're going to use a trial solution. And the trial solution for a sine function, omega s is the angular frequency of the source as opposed to the omega that we get here. Okay, so the trial solution is going to be, and of course I left the s off of my omegas here, but the trial solution is going to be of this form. The only way a series of derivatives can give us a sine function is for each of the terms to be either a sine or a cosine function, or some combination thereof. So our particular solution is going to be C1 times the sine of omega st plus C2 times the cosine of omega st. And plugging that into the equation, that you're probably not going to be able to read that, but it's just the same thing we had here. We take the derivatives. I'm not going to write this out, but the second derivative of this is negative omega squared times just what we have here. So the second derivative is going to give us negative C1 omega squared times the sine, negative C2 omega squared times the cosine of omega st. And I'd better put those s's in there before I completely forget to do that. Okay, this is omega s. This is omega s. So is this. So is this. Okay. Now, that's what we get. And then Q prime is going to be what? It's going to be C1 omega s times the cosine of omega st minus C2 omega s times the sine of omega st. Again, this is extremely straightforward. So if we just write it down carefully, we're going to have it right, and I believe that gives us a C1 times r over L omega s times the cosine minus C2 times r over L times omega s times the sine. Of course, we have the factor r over L multiplied by what we get from the derivative. And then we just have the Q over C. So it's just this divided by C, this divided by C. We get that by just doing C1 divided by C and C2 divided by C times, respectively, the sine and the cosine of omega st. And that has to equal our V naught sine of omega st. And notice I've made this kind of a fancy C here just to make sure we distinguish it from other C's like these, or like Yeah, just from these two C's. Not absolutely necessary to do that, since we have subscripts in these, and this is lowercase and this is capital, but keep it as clear as we can. Okay, now we combine these equations, and we simply take the terms that have signs on them. Sorry, just wanted to look at this, make sure I'd really done that right. We have a sign here, and a sign here. So we take those terms and collect them together, and we're going to set that equal to V naught sine of omega st. So the sine of omega st will go out of every one of those terms, and we're going to end up with this. Negative C1 omega s squared minus C2 r over L omega s plus C1 over capacitance C, and that should equal V naught. The cosine terms are going to have to add up to 0 because we have no cosine on this side. So we just get this term, and this term, and where is it, this term, and we're going to have each of those times the cosine of omega st, but it's going to end up being equal to 0, so we can divide out the cosine of omega st. We might want to worry about the case where the cosine is 0, because it is once every cycle, but we don't really need to worry about that. Okay? If you wanted to explain that, ask. Just because we're talking about multiples of functions and not the actual values, but we can deal with that. So anyhow, we get this equation, and then we need to solve these equations for C1 and C2. We'll proceed to do that in the next video.